Hey guys, so I'm going to be teaching you on 11-5 polygons, and a polygon is basically a simple closed figure but that is connected by 3 or more line segments called sides. And some of them can be, oh, no, where for a pen. There are some polygons that are not really polygons. One has the shape of a ice cream cone. Such. Can't figure this out. Yeah, one has a picture of an ice cream cone. One is a hourglass, and then one is just some freaky messed up figure like that. Alright, so this one has a curve, so that makes it not a polygon. The sides overlap right here in the middle, so no polygon. And then, just like mostly right here, this, as you can see, it's like a big gap right here, which makes it an unclosed figure, which makes it not a polygon, because it's a closed figure. Where the heck did the rest go? Why can't I find these right now? Yeah, alright, so now a diagonal is sort of like what splits a figure in half. That's like so this would be diagonal mostly in the quadrilateral. You can see that that made two triangles right here, which is very important. We'll get back to that later. And then we'll learn about the interior angles and the area of a polygon, or just a formula to find the interior angle, which would end up being n minus 2 times 180. N is the number of sides the polygon has, while 2 is, like I showed you earlier, the two triangles that are made by the split in half square. And 180 is how many degrees each triangle should add up to, unless it's something else. We'll get that's another time. Alright, now, how you figure one out is, say for example you're given a pentagon. A really screwed up pentagon, by the way. Yeah, pentagon. And since it has 5 sides, 1, 2, 3, 4, 5, it will be considered, it has 5 sides, so you put that in the number of the n, subtract it by 2. I'm writing with my left hand, so yeah, it's kind of screwed up now. So using, please excuse my dear Aunt Sally, you would subtract first, which equals 3. 3 times 180 is, that's kind of screwed up. 180 is like 140, 540 I think. And that's basically the sum of all the interior angles. Just asking you that in the problem. But if it asks you for just to find one interior angle, you'd have to backtrack a little bit. Instead of multiplying here and then get your answer, you'd have to take this answer, the product, and you'd have to divide it by the number of sides the polygon has, which is 5. And that would equal 108. Yeah, 108. So the measure of one interior angle is 108 in the pentagon. That's very nice to know. So next we're going to be learning about tessellations, which is basically line segments that do not have holes, or is basically it's closed, like a polygon. The whole reason why it's in this place. Now, there's going to be ways on how you can find a polygon, and sometimes it'll involve strange drawings and stuff and information. Now, the tessellation in an example would look like this. Not the method script, but still. yeah, so since there's 4 sides and there's 90 degrees, it'd be 4 times 90 equals 360. Mess up. Alright, so, but that's sort of the case for what we're about to do. And